Dear students, we are going to discuss about the ambient circuit law in electromagnetic theory. Well, what is ambient circuit law? Which help us to calculate the magnetic field. But the Biot-Savart's law does the same. But ambient circuit law uses the case high symmetry. That is the main difference between the ambient circuit law and the Biot circuit law. We will first understand the ambient circuit law. Introduction. It is a useful law that relates the net magnetic field along a closed loop to the electric current passing through the loop, and it first discovered by André Marie Ampère in 1826. But in classical electromagnetism, Ampère circuit's law relates the integrated magnetic field around a closed loop to the electric current passing through the loop. But you will not confuse to the Ampere's force law that André Marie discovered in 1823. Also, in 1823, André Ampère formulated a law based on Oyster's as well as his own experimental studies. At that time, this law can be regarded as an alternative expression of Biot-Savart's law, which also relates the magnetic field and the current produced. And that calculation leads to the limitation of the useful form of this law, that is, its validity only for steady currents. So we say it is a useful law that relates a net magnetic field along a closed loop to the electric current passing through the loop. And after 4 decades later, Maxwell realized that the equation provided by the Amperes was incomplete and extended his law by including that the magnetic field arises due to the electric current by giving a mathematical formulation. The Ampere's law. Ampere's circuit law states the line integral of the magnetic field over a closed path or loop equals times the total current enclosed by that closed loop. We express this law through the mathematical expression integral B dot dl equal to mu 0 into I. That is, I is the net current enclosed by the loop. Mu 0, the permeability of the free space, that is the 4 pi 10 raised to minus 15 Newton per ampere square. That is the Ampere's law. There are so many applications in the Ampere circuit law. In this case study, we have to discuss one main applications of the Ampere circuit law. Here the main application of the Ampere circuit law. Magnetic field of a toroidal solenoid. Here is a toroidal solenoid. The figure shows a duffnet shaped toroid solenoid. This is a duffnet shaped toroid solenoid wound with n turns of wire, that is a n turns of wire, carrying a current I. This is a current I. Finding the magnetic field at all points. We had to find the magnetic field at all points. From Ampere circuit law, we already know the integral B dot dl equal to mu 0 into I enclosed. That is the mu 0 into I enclosed. That is the I. Let us consider path 1. This is the path 1. No current is enclosed by the path. You can see that no current is enclosed by this path 1. Hence, the magnetic field along the path is 0. No current is enclosed in the path 1. The current is 0. And the magnetic field is also 0. Then we have to consider the path 3. This is the path 3. The outermost area is the path 3. The net current enclosed by the path is 0. In the path 3 also the net current enclosed is 0. Hence the magnetic field along the path is 0. So the magnetic field along this path is 0. And consider path 2. then we have to consider the path 2. From the path 2 we can see that B into 2 pi r, according to the according to the Ampere's circuit law, B into 2 pi r equal to mu 0 into n into I. N is the number of turns, I is the current. B equal to mu 0, the permeability of the free space, mu 0 into Ni by 2 pi r. This is a main application of a Ampere's circuit law. Then we have to discuss about the limitation of the Ampere's circuit law. We already know it is in the classical electromagnetism. Ampere's circuit law relates the integrated magnetic field around a closed loop to the electric current passing through the loop. So the limitation of Ampere's circuit law is valid only for steady currents. The conventional form of Ampere's circuit law was pointed out by Maxwell. He introduced the concept of displacement currents to generalize Ampere's circuit law even for non-steady currents. That is a main limitation with relate to the Ampere's circuit law. It was this generalization that played a crucial and central role in the development of Maxwell's electromagnetic theory of light. Thank you.